Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Kavanaugh. I will be your moderator for today's event, in which we're going to talk about one of the most far-reaching and significant topics in this business so far as I'm concerned. We're going to be talking about this whole concept of conceptual modeling. So I think many of you know that conceptual modeling is a very useful practice for getting a picture of what is going on out there in your information environment. So the topic today is designing a better future, how architecture enables agility and alignment. So let's just get the ball rolling here. There's a slide about yours truly and enough about me. The mission, of course, as many of you now know, is to reveal the essential characteristics of enterprise software. We're trying to get down into the weeds and understand exactly what these different technologies do, how they work, and why they work a certain way. So we're going to be first hearing from a vendor, namely David Dickman of Sybase. He's going to go for 20 minutes. Then we will hear from William McKnight. And then after McKnight presents, he's just going to start asking questions. So this is a live, unscripted analyst briefing. In other words, once we get through the formalized presentations, it's just an analyst briefing that you get to benefit from. So you can see we cover different topics every month. January is the architecture month. February is performance. You can see the other months coming up. We do that because I'm trying to put myself in the shoes of the end users and imagine what it's like to try to figure out what these different technologies do, because when you have to make a decision about which technology to buy, as many of you know, these solutions tend to be fairly expensive. Even the ones that are reasonably priced are not what we would call cheap. So we're trying to help you get that apples-to-apples comparison that's going to allow you to figure out exactly what kind of technologies you need and the specific ones that can suit your needs. So the topic of the month is architecture. Many of you may have heard about a report we did last year on the information-oriented architecture, and the purpose of that report was really to demonstrate that gaining a strategic view of information assets is becoming ever more critical in the world today, and that's the case for all kinds of reasons, one of which simply being the heterogeneity of information systems. There are so many platforms, there are so many devices now. Of course, we know that SAP bought Sybase in part for its mobile strategy. Mobile, of course, is everywhere these days, iPads and Androids and all kinds of different devices out there, BlackBerries. We won't get too much into that today, I don't think, but the point is that if you have that strategic view of your enterprise architecture, you have a leg up in terms of things like agility and alignment. You can see what's going on there. You can head off problems before they occur, and that's extremely valuable in these environments that we have today. So data modeling, yes, it's been around for a long time, but how well has it been used? That's another question, it seems to me. We'll be getting into how data modeling and conceptual modeling can be used to help you figure out what's going on and basically streamline integration, your data integration, your ETL, streamline things like master data management, which I think we all know is rising in prominence because of how heterogeneous the world is today. And that gives you agility, it gives you alignment, it allows you to respond very quickly to changes in the marketplace, and we all know how fast those can happen these days. So our analyst today is William McKnight. He is a strategist, a lead enterprise information architect. He has a tremendous amount of experience in this field and in MDM, of course, in data warehousing and data quality. So we're very pleased to have you on board today. Sybase, power designer. So, of course, it's now Sybase, an SAP company. They have a broad portfolio of BI, data management, and development products. Power Designer is a modeling solution for architects, analysts, DBAs, and developers. You can see some more information about that here. It's a very mature product, folks. These guys have been doing this stuff for a while. And David Dickman, who is going to be presenting, has a lot of experience in this field, so we're pleased to have him online. And there's David. He's the product line manager for design tools at Sybase. He's been here before in the briefing room, so he knows the ropes. And so, David, I'm going to go ahead and hand you the keys to the car, and you should just be able to click on that slide and then use the down arrow and be off to the races.
Excellent. Thank you very much, Eric, and I am very pleased to be here. And what I'd like to talk to you folks today a little bit about how we see architecture and I'll explain what I mean by the word architecture in a moment, is enabling the agility and alignment needed to be able to help us with managing information problems. So when we think about information problems, we think about the kinds of solutions we're bringing to bear today, whether it be things like master data management or data warehousing, business intelligence. Whatever it is we're trying to get out of our information, what we're doing is we're looking at information now more and more as a true top-shelf corporate resource. This is something that we need to help run our businesses better, just like any other asset that we manage in our enterprise, whether it be human resources and talent, whether it be physical desks, chairs, whatever it is. Information is an asset that we're going to be using in all of our business processes and to help us make better business decisions, and we're going to need to treat that really as something that has to be well managed. When we think of information as a corporate resource, several qualities come to bear, and the first, of course, is making sure that that information is of high quality. Garbage in, garbage out definitely applies to anything that we do with our information and our information systems. But this also needs to be cross-system. We can't just be getting information from one pocket or one corner of the business and use that as a corporate resource. So we need to look at all of the different systems and how they all manage intersecting and overlapping bits of information. And we need to think about this as an enterprise-wide focus, not just in one work group, not just in one area, but really how do we all treat information all together across the enterprise? Because ultimately what we're looking to get is a single source, single version of the truth that we can leverage for better understanding of what it is we have, how these applications can work together and communicate in a streamlined and more effective way, and how we can leverage that information for better decision-making purposes. So we need that harmonized, superset view of information. And, of course, when it comes to getting that and getting that right, you need to get a lot of different people involved. And these people need to all understand how to communicate, collaborate effectively together. And the key to that really is having this as a governed process, having that governance in there, assigning stewardship. And I know when we start talking about governance, one of the things a lot of folks react to is, well, we don't need more stinking rules. We've got enough rules. We're not talking about a kind of set of rules to force us into a constrained set, but really a set of ways of communicating and collaborating more effectively together so that every stakeholder can have their viewpoint and perspective well represented as the decisions are made forward. And architecture provides that. Architecture first and foremost provides a way of being able to give the right abstractions. And unfortunately, these slides didn't translate, but the word simplification here in bright red, I'm actually crossing out here. We don't think of abstraction as just simplifying what you see so you see less. We're actually talking really about fundamentally the idea of ease of use. If I present the right level of information to the right stakeholder at the right time for their viewpoint, for their perspective, then it's easy to use. It's easy to communicate, it's easy to collaborate, and it's easy to understand. But if that is truly aligned with how we're going to represent that in systems, what the logical and physical representations are going to be as we build applications and solutions on technology, then this ease of use to be able to communicate and collaborate at the enterprise level translates directly into actionable architectural change to our enterprise systems. And that's what this is about. This is about planning for change. So architecture is the key value in any planning cycle. So whenever we're moving towards something like master data management, first generation or improving on iterations over time, we need a plan. Business intelligence, data warehousing, we need a plan. The planning is about getting better decisioning. It's about leveraging what we know and what we've got, leveraging that information so that we can make the right decisions at the right time, not just about decisions during active business processes. That's what business intelligence is helping us get to. And that's where things like Eric was talking about, this wave of mobility and being able to deliver information to the point of action. This is about getting the people who need to make decisions, whether they be our customers and prospects or our frontline managers, giving them the right information in real time to make the best decisions to improve business process. That's what this is about. It's about that agile enterprise, but it's also about the back office. It's about transforming our business and our business practices and our information systems in an agile way, and both need to go hand in hand. So governance is a key player in that. Getting the stakeholder involvement is a key player in that, and that's having the right visualization for the right people at the right time. But being able to keep everything in sync, because we're not going to as a lot of folks have done in the past, take something like a conceptual model, sign off on it, deliver that as written law, and then build systems from that. We're going to discover new things during systems development, during implementation, during the next business review that need to iteratively cycle through all of these things. So all of this must be thought of as iterative and transformative living documents. And that's really where we come up with this idea of a live architecture. The architecture is this living, breathing, constantly changing environment that is keeping up with every phase and every stage of the plan and every new discovery we make. And the key to tying all of this together is the metadata, this metadata providing the context for every viewpoint, every perspective, linked to development and linked to business. This is what's going to get us this agile enterprise. So when we start thinking about all of these different things that people are going to use to communicate and collaborate architecture and start to try and come up with what is the right way to understand everything in a holistic way, we understand there's a lot of different pieces of the information architecture, many different tools and techniques that we use, everything from, as you see in the bottom left corner, things like a requirements document, or in the top right, a representation of a hierarchical model, an XML representation, or business process models, again on the left, logical physical data models through the middle into the bottom right, or the data transformation processes we'll find in ETL and EII. All of these things are things we know about our data. What does it mean? Where did we put it? Who's using it and why? Whether it's an XML message or a physical table in a database, or whether it's being moved and transformed through various systems, we need to know all of those things. And interestingly enough, the knowledge we have about our architecture comes from sources that aren't so formalized. They come from Word docs and Excel spreadsheets or PowerPoint presentations, or my favorite, sticky notes, which is probably the least persistent of all of these models and one of the most prevalent. And what this is all telling me is, in order for us to get business and IT alignment, we need to be able to work with not just the IT models, the logical and the physical models that you saw in the previous chart, but also capture the business essence, which is coming from non-modeling types of knowledge bases like documents and spreadsheets. And we need to bring all of these things together in such a way that they all contribute to our knowledge. And that's really the key of contextual and conceptual modeling, providing a single enterprise-wide representation of the business view of what we do in process, what it means in data, how that ties together, and then relates to all of the different physical implementations and through logical and physical modeling, whether it be process orchestration or database definitions, and keep that all aligned. And that's what we've built into Power Designer. The one key differentiator, the thing that really makes the difference these days, is being able to not just have all these models, not be able to have just one conceptual enterprise model. And by the way, the reason why I keep stressing that one version of the truth on the conceptual model is that's really what we see, is this idea that when I think about, for example, something like customer, I don't want to model conceptually customer for order entry. If I am constraining my conceptual representation of customer to a purpose of order entry, I'm already missing the point. What I want to do is think about customer in all of its business use cases. So for order entry, for example, I need name, address, phone number, and method of payment, for example. When I think about the customer concept for customer relationship management, I also want to know things like age range, income, and other demographic details that help me build a better relationship with my customer. And those are going to be stored in other systems, but the conceptual model needs to be the superset of all use cases, and perhaps even additional information that will only exist in its conceptual representation that may lead to something that will be physicalized in master data, for example, that give us an idea of what this means to the whole of the business. And then it will be transformed into multiple logical and physical systems that represent databases for the various different applications that are feeding the various different use cases and business processes. We need to bring all of that together. But we need to be able to do so in such a way that all of these models communicate and collaborate effectively. That's what Link and Sync technology does. It allows us to take models that are representations of import from Visio or import and export from Excel. It allows us to reverse engineer on the physical side, business process orchestration languages, object-oriented languages, XML structures, and of course databases, whether they be running database catalogs that we can extract metadata from, or database DDL scripts, data movement scripts, whatever it is that we have, we can bring these into the physical levels and then use link and sync to transform them into logical and feed into conceptual representations and feed things back down in an iteratively changing manner. And this way, we're able to truly align all the stakeholder viewpoints and all the different perspectives and let each one live with its own life cycle, yet communicate and collaborate between them all. That allows us to truly drive transformative change from business through IT. So the key enablers that architecture is going to give us, the key things that we're looking to get with this architecture-driven agility for master data management, data warehouse, business intelligence, or whatever it is that we're doing with information architecture to be able to solve information problems within our enterprise, is by using this idea of this fully integrated modeling, fully integrated business models that are linked to conceptual data models that fully transform iteratively into logical and physical models, and while doing so, maintaining traceability either up and down this heritage and lineage chain from business through to technical, or through data movement models aligning all the physical systems together. Keeping all of that in sync with full heritage and lineage give us that model lifestyle, gives us that ability to continuously and iteratively track changes from current state to future state. And what it really does is it gives us this ability to truly predict and analyze what's going to happen to our business if we make a business process change, or what's going to happen to our technology if we make a physical implementation change. That enterprise-wide impact analysis driven by a single tool using a scalable and secure repository with full notification to ensure that everyone that needs to communicate and collaborate is getting told when things are changing, when things are impacting, gets us to work together. This enables us to apply governance, and this enables us to apply stewardship in a collaborative way as opposed to a top-down forced way. And that's really what we're looking for, because with that we get change management. Change management is what lets us operationalize architecture so that we can steer our businesses and steer our IT using the architecture plan to drive the roadmap of systems and how these systems fit together. This will reduce the impedance mismatch on different systems we're looking to integrate and federate, and will, for future generations of systems, allow them to start in a more aligned and more contained way that improves the quality out of the gate, that improves the agility of the information to deliver it to the point of action and get us to run a better business. So when we compare ourselves to traditional data modeling tools, and this is where we really see ourselves creating a lot of newsworthy capability, is this idea that traditional data modeling tools, while a lot of these capabilities may be able to be brought to bear, they're either not there or available in separate tools. And when you have separate tools, you have separate repositories, you have separate disconnects, and these media breaks make it very difficult to get the traceability. So for example, requirements, fully integrated. Conceptual and business models, fully integrated. If you try and trace a requirement to a conceptual data modeling element, to the business process that it relates to, in most other data modeling scenarios, you're going to be using separate tools. You're going to have to use Excel spreadsheets to keep them together, or import, export, and fairly cumbersome techniques to keep them together. And that slows down the process, and that takes away the value that information architecture can provide. Of course, all these modeling tools provide solid logical and physical data modeling, getting the database up and running from a schema to a physical representation to the database. That's a given. But being able to include hierarchical XML modeling, not just from the physical representation as an XML document is defined, but from a canonical model that represents messaging coming out of the messaging group and aligning that with the business concepts in the conceptual model and iteratively transform those. Or how the data movement happens. We're either using, again, separate tools, or we're using what comes in our ETL environments for the metadata there, or we have nothing. And again, when a physical object is not just stored in the database, but that data is reused in many other systems, the cascading impact of a change needs to be understood before we can roll that out. Single unified repository for all these modeling artifacts give us the ability for PowerDesigner to apply that link and sync technology and then deliver that metadata to anybody, anywhere. Not everybody's going to be an experienced modeler, and especially when we're building well-built conceptual models and well-built business process models, we need data line of business. We need data professionals from the line of business, from these non-technical organizations to come together, and the portal gives us that. Web-based user interface to browse the metadata so non-modelers can see and also communicate back through metadata authoring over the web, communicate back recommended changes to be accepted and adopted into the architectural models and rolled into physical implementation. Full round-trip engineering, full round-trip version control, and full enterprise-wide impact analysis can only be possible when these things are all grouped together with an engine that truly understands how all this metadata is supposed to work together. Not taking a conceptual model and making it a logical physical, but generating and keeping them separate and allowing them to communicate between them. That's the key. So here we have Power Designer. We see Power Designer is actually sold in many different flavors depending on the kinds of modeling you're looking for. If you are really that traditional data modeling user, logical physical modeling is where you're at, the Data Architect products are there for you. But if you're looking at aligning the data modeling and using that as part of an information architecture, you want to add data movement models, conceptual data models, and business models. That'll be found in our Information Architect product. And if you're looking at not just information architecture as one of the pillars of architecture, but all the other things like application architecture and technology architecture and business architecture, you want to move to the Enterprise Architect product that adds the full UML capabilities and a series of business models in the Enterprise Architecture model like org chart and city planning and network topology maps that give you every piece of knowledge. Not only will you know what your data looks like and what system it's in, you'll know what server it's on and what the firewalls look like. And all of that, when you start getting a lot of these models together, need the governance that comes from an Enterprise Architecture framework. Things like the Open Groups TOGAF or the Zachman framework for enterprise architecture. These things provide a way of classifying, understanding, and managing all of the different deliverables that come into a rich, mature architectural framework. And Power Designer supports the easy configuration of all of those. So, of course, if you've liked what you've seen so far about Power Designer and want to explore it more, we've got lots of great information for you on our webpage. You can go to www.sybase.com/PowerDesigner. And if you want to try the product for yourself, you can download the evaluation version. There's a download trial button. You just need to click on that. And the best way to try Power Designer is a couple of really good ways. One is you get your hands on the product and start working with your models, importing from various different sources, get the metadata in there and play with it. But the absolute best way is to let us know what you're looking at and ask for a customized one-on-one demonstration. Our system consultants and field engineers are really happy to take your specific needs and build a custom demo just for you on how we can help you solve your information problems. Every organization's needs are different, and we're there to help understand and help you manage life accordingly.
Okay,
so
great.
At this point, go ahead, Eric.
Yeah, okay, good. Let me go ahead and pass the keys over to William. So, William, I think you now have them. Just click anywhere on that slide and use your down arrow, and you should be able to get to your slides.
Okay, thank you. Thank you, David, for that, and Eric. David, I was clicking away here on the slide trying to get the my download trial, but it's not hyperlinked, so I guess I will have to do that when we're done. So, William McKnight, and really glad to be with you today. And I want to just underscore some of the things that David was saying about architecture and where architecture is going and why it's become even more important than ever. And I'm actually very excited about the news you're bringing to us here today as well. And in a few minutes here, I'm going to have some questions for you, David, and hopefully everybody enjoys them. And you can actually participate as well in the Q&A section here. So give me a few minutes to talk about information architecture first. And as we can see, business value changes through time. It starts out being very important if we can get to it right away, but there are so many latencies involved in information. We don't even realize what those latencies are, but those latencies are becoming increasingly intolerable. In the work that I do with many clients, they don't even realize the latencies and then the value that there is in squeezing those latencies out of capturing the information, analyzing it, and making decisions on it finally. So this has very serious implications upon architecture. And the reason we need to model our architecture is because it's getting more complicated. There are so many, I don't want to say new things, but there are so many capabilities that are out there that are ready for us to be taking advantage of within our organizations. And as we begin to understand that information is a prime asset of the company, we begin to realize that we have to take care of it in the very best way possible. And that means anymore that we cannot wait for that single database, be it a data warehouse or what have you, to do it all for the organization. And organizations rapidly are adapting other technologies to siphon off particular workloads to do the things that they are best suited for. And I'm going to talk a little bit about that as we go on here. Here's a slide from eBay. Now, I don't have time to go into any of this in great detail, but as you can see, they have a variety of characteristics that they've put on this spider graph. And around the edges of this spider graph, you can see the things that they measure every workload against. Does it have high workload management, high concurrency requirements, et cetera, et cetera? Now, without putting too fine a point on it today, as you can see, some things belong in the EDW, some things belong in Hadoop, which I'll talk a little bit about here, and some things belong in something else entirely. Now, we all don't have the resources to build what they did. They call it a singularity. But we do have other options as well. And this is just really here to show you that it's eBay, it's companies like that that are having to look at workloads and decide which platform to send different workloads to. Technologies that help improve performance top the list of those that are being adapted more. So it's all about performance. And when a company realizes that it can take advantage of the performance, that it can take advantage of squeezing those latencies out of their workloads, they begin to adapt technologies such as what you see here, in-database analytics, columnar databases, massively parallel processing databases, solid-state drives, NoSQL, MapReduce, and Hadoop. So let me talk a little bit about some of them. This is an attainable holy grail of architecture. It's something that many of my clients are striving for in one way, shape, or form. Generally speaking, what we see on here are a lot of components of information architecture today that are relevant to so many shops. Now, the previous holy grail was much cleaner, much simpler. We were trying to build everything into a data warehouse, almost into story. But today, we have so many more components that handle specific workloads, like Hadoop handles unstructured data much better than the data warehouse. And actually, it's picking up unstructured data that we have not put under management pretty much at all to date. And now we're realizing, hey, that's a new battleground that we need to be out there upon, and we need the most elegant tool for that. We don't want to pay an arm and a leg for it, but we need an elegant tool to handle that type of information. And so we have, as you can see throughout here, we have massive data interchange going on. That's important. We may have even a data virtualization layer across the top of this, taking some edge workloads off when you have to go from one technology base to another. And then you have, of course, the data warehouse. And then you might have a columnar data store, which are good for a particular type of workloads. You might have a data warehouse appliance in there. And I put that at a second tier, sort of at a data mart level from the data warehouse, but many of you are putting it up there beside the data warehouse in your tier. And that can be right as well. Things are moving so fast these days that if anybody's waiting for it to be a nice clean sheet of paper, that's just not how it's going to go down. Things are going to be coming into the environment either in a heads-up fashion or in a bottoms-up fashion, unarchitected fashion. But it's all about trying to get maximum performance out of the information asset within the organization. Other things on here that I might point out, a lot of the elements that you see on the analytical side and on the operational side, I might add, are moving into the cloud. And that has other serious ramifications we can't go into today, but that also complicates the architecture because now it's physically separated. And on the operational side, we have innovation there. We have master data management. One of the strong movements there that is actually moving cycles off of the data warehouse that used to belong in the data warehouse. So what does that do? Obviously, that's going to manage the master data of the organization and originate much of it through workflow processes. We are bringing in syndicated data, maybe to the master data management hub, maybe to the data warehouse or someplace else. But we're largely taking up the fact that there is a data marketplace that we need to avail ourselves of. And, of course, we have a lot of legacy sources that are relational. We have a lot of data stream processing going on now, which is things that don't need the massive integration that occurs within a data warehouse, things that have to happen right away, things that you can augment maybe with master data, and you can look at transactions as they occur and do something about them. So fraud, for example, different examples of things that are being done with data stream processing. Now, in the cloud, I mentioned the cloud. There's so many different aspects of the cloud. You see that there is software as a service, and then there's increasing value that you can get out of cloud as you go from actually infrastructure as a service all the way through software as a service. So there's increasing levels there of function that you might be getting out of the cloud. There's also different deployment models. You can go public, you can go private, you can go hybrid. And private cloud is really taking off, and that's data virtualization, architecture virtualization, which is getting us increasingly away from the machines that are holding our data. So those of us that really like that intimate relationship with our machines, that's being removed so that we can get more efficient. And then you see various application domains, whether it's analytics, CRM, the database itself, which is a large first port for cloud, storage, ETL, there's a lot of different application domains. So just to say one is moving to the cloud is really not enough. What services, what deployment model, what application domain, and how much at once. So there's a lot of factors in there that are complicating our architecture. That's really the point for today. Now today, I'm not going to go through this in any great detail. Download the slides if you want them. You can get this as well. Down the left-hand side, you can see all the various data stores that are relevant today to many enterprises. And across the top, you see some of the criteria by which you would analyze workloads. And then you can see where you have a thumbs up, where you can see where that workload is going to be appropriate for that particular data store. Not every data store is appropriate for every workload. I should put it differently. Not every data store is going to be optimized for a given workload. We can always force fit, but force-fitting solutions into ill-fitting architectures and ill-fitting data stores is what generates so much of the problems out there with information. Not every database is architected to store historical data or give you access in real time, etc. Yet we get that nail and we get our hammer out, and it's the one hammer oftentimes that we want to use. And that's what I want to encourage us to try to get away from, which is bringing out that one hammer for our problems. There are many today, and our architectures are getting more complicated. We need tools to help keep our architecture picture up to date, and we need to get there fast. This is the traditional approach. I've had this on my wall forever, as many of you have as well, if you're a data warehouse professional. However, some challenges with the traditional approach. Many of the functions that we saw there need to get done. Don't get me wrong. Most of them need to be done. But the traditional approach can get us there on a slower pace than our business would like, than our funding would like, than our reputations and our legacy would like. So we need to speed those things up. And we can talk about Scrum perhaps in the Q&A, but that is a way to speed things up and get us to our desired architecture quickly. And we need to get there quickly and fail fast, as it were, and keep iterating and keep improving architecture. It's not a one and done. The architecture must be tended to. It's live and dynamic, especially today, as we are taking on a lot of the things that I just talked to us about. Columnar, cloud, Hadoop, stream processing, MDM, data warehouse appliances. And of course, we have our data warehouse. We have our marts. Some of them are cubes. It's getting really complicated out there, folks. And so it's almost by design. We can let it go to complete chaos, or we can try to rein it in and manage it and roll it out in a sensible, efficient approach. Of course, I advocate the latter. So now I'd like to bring David back in. And David, are you there?
I am, yes, thank you.
All right. It's time for us to have a briefing. And I have some questions for you, as you can see here. So first of all, how'd I do? Do you agree with me? Do you believe that architecture is going more heterogeneous and it's going there fast?
Well, absolutely. I think it's the heterogeneity. I can't even pronounce that word, but you said it so excellently earlier. I think it was Eric who said it. Heterogeneity, or the heterogeneous nature of the systems that we're dealing with, is actually creating more and more need for architecture, more and more need to be able to manage all of these different looking and different feeling constituent parts and all of the different data sources as we struggle to integrate and federate, we're not actually reducing the places where information comes from, but as you've said, with the new incoming data streams and syndicated data and the data marketplace, we're getting things from more and more diverse places. And some of us are being forced through regulation to produce and consume these things in constantly changing ways. And
That's
as
true.
we look at SAP's model with mobility and being able to deliver information to the right people at the right time, we're going to all these different number of devices and number of applications. So architecture is going to be giving us the control that we need to be able to manage that. And a good friend of mine says it best. If we think of architecture versus implementing, this is like Boeing putting bigger and bigger wings on the plane until it stops falling out of the sky. Architecture is the plan to do it right, and we're building our data systems this way. We're patching and fixing until it stops breaking, and we need a better way.
We do. That's so much of my work right there, actually. And you bring in another important dynamic to architecture, which is the deployment method. So mobility is hot, actually, and I didn't even represent that. So that's another important factor of architecture today. Now, the second bullet, we all know how data modeling tools support the build of a single database. I assume that we know that. But what about the build of an architecture? In other words, what is different about data modeling, and architecture modeling, which you've come here to tell us about architecture modeling. So what's different about it? Are there some new icons that we can be using? Are there new things we need to think about as we do an architecture model?
Absolutely. So data modeling and traditional route of logical physical modeling is really an IT discipline there to help us, as you say, build out this single database or a series of data assets for a given application or project. And I usually, when I start hearing the words application or project, immediately start saying, okay, let's stop and start talking about this a different way. And the different way is thinking architecturally first. First and foremost, I mean, we've had these disciplines for a number of years. I think we saw a comment earlier as we were getting ready that conceptual modeling's been around for 2 decades. What's new and what's different? Fundamentally, what's new and different is not that it's the conceptual model itself, but that we've got to start using it. We've got to start using it right. What makes architectural modeling different is we abstract ourselves from how we're going to store it, what paradigm we're using it, what we're physically doing to optimize its load and save times and these kinds of things, and start thinking about what does it mean? Why is it there? What does it do? Who cares? What's it for? The 6 primitive interrogatives that John Zachman talks about: who, what, when, where, why, and how. And those questions are answered at an architectural level as it relates to business strategy across the enterprise. One single representation across the enterprise. And then that relates to and can transform to multiple logical and physical touch points, whether it be a message through canonical model to message model, or logical physical data models, or a object-oriented model to build persistence in components. If we architect first, these things will be more closely aligned, or we can at least find which ones should be more closely aligned and identify the impedance mismatch more effectively. And that's what architecture gives us, is the plan to be able to do that.
Okay. So no doubt, I see that value proposition. Let me take us down into the weeds of this, so just a tad more here on that particular question. So I'm trying to design my architecture with Power Designer. I want to show whatever the data interchange might be between my HDFS database and my data warehouse. Are there certain icons I can use to show that? And what about the timing of the movement of that data? Can that be represented in the architecture?
Sure. So there's a couple of different artifacts that I would bring to bear for that. And one would be from the enterprise architecture model. We can actually draw a diagram with new icons. We'll draw a data warehouse and an ISS system, and we'll draw the communication between them. And conceptually, that tells us and tells the business, this is where these things are at, and this is how we're going to wire them together, and it helps systems planners understand that. But at the detailed level, well, which piece of information, how does it get there, and what's the path? Well, the data movement model provides us that. And while it's not necessarily new icons and new visualizations, what we've done with Power Designer is we've created a logical data movement model that allows us to be able to take all of those physical data movement topologies in Informatica and Ab Initio and business objects and all these other things and put them together in a single map that spans the enterprise. So all data movement from all data systems has one representation, so that not only can I say, hey, this thing has Informatica working on it, it also has Ab Initio, it also has Microsoft still says this and that. And that gives us yet another dimension of being able to document, define, and describe how these things come together.
Okay. Yes, that's really important. It's one of the things I do a lot, which is architecture modeling. So I definitely see the importance. Many of us are visual thinkers, and so just having that architecture out there visually, it's a shareable thing. It also shows that information architecture should be a coherent whole, and that we shouldn't have it all piecemealed out. And so it has to hang together, and a model can show how it does that. My next question is something I'm very curious about. One of the advantages of a lot of the NoSQL solutions is that they are schemaless, which gives you a lot more flexibility with how you access that data. But what's the solution to modeling in the schemaless world of NoSQL?
Well, that's interesting, because what we've done with things like NoSQL, and it's really very parallel to the same problems we face in unstructured data, is we've taken away the precision of the physical definition of the container and the details of the storage within it. That's gone. We don't have this ability to say, this is the table, and this in this cell within this row of this column has this kind of information. That's gone now. That's with things like NoSQL is a bit more amorphic, or with unstructured data completely unattainable. So what becomes important is the modeling that provides us an understanding of the business language and its context, because now we're less interested in how we put it in there and how we get it out. We're definitely much more interested in what does it all mean. And that's, again, where we have the value of conceptual modeling, and above that, things like business glossaries and taxonomies and ontologies. And these other structures allow us to say, these are the meanings of terms, these are the meanings of cells of information in my business. This is what I'm looking for and how I want to get at that, and feed that kind of model into the systems that perform the analytics on these unstructured and semi-structured formats to get us meaningful and useful results. So more and more, the architecture of our information, independent of database, independent of structure and format, becomes the cornerstone to being able to use this information in an effective way.
That's a good answer. That's a good answer. The way to look at it then is that you're modeling the data that is sort of the buffet that the schema can come and select from for its particular need. Now, even though we say, or they say that we're schema-less, they still have a schema. It's just very dynamic, and it can change. So I do see that there's applicability in traditional modeling to NoSQL, but you put a good fine point on it in terms of the flexibility that's now needed in that world. Next question is the need for a single integrated view of strategic corporate data something we've been pushing and striving for? Is that still relevant now that we're going to have so many different data stores holding information across the enterprise?
Well, from my perspective, and where a lot of our customers have been very successful in solving what I call information problems, it absolutely is. A story that I'd like to say in these kinds of discussions is we're working with a corporation that was a sum of many parts through acquisition. This is actually a shipping company. And the problem they were facing was actually something that was exposed to the customer. When you wanted to ship a package through this organization, you had to tell them what method you wanted to use for shipment. If you wanted it ground transportation, air transportation, oversea, because there was a different form for that. And what made things even worse is at times you say, well, I don't want to pay for air shipment, but I'm going from Boston to California. Oh, well, that's going to be the ground shipment that ends up in an airplane. Here's yet a different form for you because we don't know how to pay the different parts of our own company for the different parts that are going to be used to convey the package. What they found when they started to build a single corporate view of data, an information architecture at the conceptual level, was that things like package, container, shipment, deliverable, these words were used completely inconsistently across the different businesses divisions. For example, on the airplane, a package was full of containers that had shipments full of deliverables. Or on the boat, a deliverable was full of shipments that had packages full of containers. And this is just a simple example of the many, many business language inconsistencies they found that prevented their integration efforts at the technical level because they weren't that visible at that level. Well, after solving the business language problems, they had integration within 6 months. And now you pay for a guaranteed time of delivery, and you don't care if it ends up on an airplane, they use a catapult or a tunnel underground to get it there. They get it there by the guaranteed time that you've paid for. That's how shippers want to integrate with folks like Amazon.com. That's how consumers want to pay for shipping. They saved their business by solving a language problem. So that single integrated view of strategic corporate data tells us what it is, why we need it, how it represents everything, and then we can map that to all the different stores, structured or unstructured, purchased or internally controlled, and make sure that we're all speaking the same language, communicating, collaborating effectively to make the business run better.
Great. Okay, I couldn't answer it better myself. I had an example as well, but I definitely answered this with a resounding yes as well. And I don't want to solution it now, but that's sort of the idea behind master data management. It's getting that common definition out there across the enterprise. Now, next slide here we have, is it important for the modeling activity to directly manage what it builds? In other words, if I do the model in a tool, is it important that I maintain the link between that model and the database that it is installed in, so that when I need to do changes to the data model, I can do the changes in the modeling tool, and it will automatically stay in sync?
Well, I think there's a lot of different ways to answer that, but the best way that we see these days is best practice organizations, one with a fairly mature discipline around architecture, lead with architecture and allow that to drive the various iterations of the transformation from current state to future state, even at that granular level. So in that context, then, it absolutely is essential that when we're at that physical level of the models, that those models truly represent and round-trip synchronize with what they build, whether it be a physical database system, whether it be a message format, or it be a set of components that are used to become services in our architecture, or the process orchestration languages, that those round-trip tight synchronizations are there, which means we're actually going to have a massive proliferation of physical models representing this massive proliferation of physical touch points. You know, Sybase is a great example as a database company and a company of acquisitions. Even before being bought by SAP, we did an exercise where we discovered that we managed customer information in over 350 different places. And most of those were actually quite relevant to the way we ran our business and needed to be rectified, not removed. So that is absolutely true. But what's essential to this, and the next step for this, is making sure that all of those physical representations also are rectified against the single conceptual representation through the various levels of abstraction that may be necessary to get that highly specific physical representation from various generalizations, and keeping that synchronized and round-tripping between transformations up and down that stream is also going to be critical. So changing a table in a database could impact the business representation of, for example, customer or order. And we need to know if it does, and if it does, we need to make sure that we get the right stewards involved and so forth. We need to have this whole process brought into bear, not just making sure that the physical models represent what's real.
Okay, great. I think it's pretty important for the logical model to be up to date, and that doesn't change nearly as much as sometimes the physical model does. And it's something that it sounds so innocuous, should we do this? But it's something that we deal with on a client-by-client basis, and I try to hold the same line that you talked about there. But backing up a little bit from that, the data model itself, and now I know I'm talking about data models, not so much architecture models, but we're all out there, doing data modeling now, and it's so highly leverageable throughout the enterprise. Yet I still find so many companies trying really hard to avoid doing any data modeling, or when they have to, it's when their back is up against the wall and the pressure's on. Do you still find that dynamic at play in organizations, or do you see organizations finally understanding the value of data modeling and that it's part of the normal life cycle?
Well, I think organizational culture definitely plays a role in how much importance is given to the need for data modeling. We find the more complex an organization is, the more they've had the opportunity to realize the value of data modeling. But an old boss of mine said it best, until they've bloodied their nose, they don't know that they're missing this. Yeah. And a lot of organizations, you can get by with what we call the cowboys on keyboards And this is, as I said, it's like Boeing putting bigger and bigger wings on the plane until it stops falling out of the sky. If you've got the time to invest and the resources to invest in that plan, you may actually pull it off. But at some point, something's going to fail, and it's going to come back to bite you. And organizations that have had the complexity as part of their life cycle long enough have been bloodied long enough to realize they need it, and they make it part of their culture. Those that haven't, those that are more perhaps innovative versus process-driven, tend not to. And for the most part, it's either working with their culture and getting them to get the right value from the right pieces at the right time, or it's waiting for them to bloody their nose and realize that they need something to help them solve their information problems in a more sophisticated way.
Absolutely. That's great. Okay, so let me get on with the next question. While data is becoming democratized, is data modeling becoming democratized also? So you just mentioned how important it was, how many organizations have got their nose bloodied, been through all that. Now they're accepting the data modeling discipline. So is IT still doing it all? Or do you see business areas picking that up just like they're picking up much of their reporting activity these days?
That becomes part of the communication and collaboration dimension of this whole thing, and that's why I love to go back to John Zachman's enterprise framework. Really, there's various different levels of representation. This comes back to the whole idea that there are viewpoints and perspectives. If you study any of the enterprise architecture literature that's out there, different people look at the world from different ways. Data modeling, frontline data modeling about the database systems, that really still is traditionally an IT function and probably should be. But what we're seeing is a lot of organizations taking their data models to the business, even teaching business subject matter experts and business area owners how to read them and interpret them and understand them. The challenge with that, of course, is we're now asking non-technical people to be able to read things like a foreign key or understand the value of a well-placed index. And that isn't necessarily what we're trying to accomplish here. So to one degree, I think we are seeing a kind of democratization of data modeling by getting more and more people involved in the structure. But what we're actually doing is seeing a surrogate for the kind of discipline that would go into a well-stratified architectural representation of data as it relates to multiple projects. And so we're still leading with the project, leading with the application or the database system that we're building for a given purpose, and collecting the data to manage that and backfilling the architecture through understanding the business and getting the business involved then, and instead of having an architecture there in the first place and just doing the next iteration.
Okay. That kind of leads into my next question, the last one on the slide here. So what about information architecture? We're talking now about information architecture. I know we're just introducing the concept really in terms of the tool, but who do you foresee doing this? Are there going to be more central architecture groups? Is that kind of who you're targeting with this?
What we're looking for, and the organizations that we've been successful in helping with Power Designer as part of their architectural practice, have built a discipline around that. We're seeing titles like information architect or enterprise architect now picking up the discipline and looking at things from that more business-aligned, business-centric way. And what's interesting is our approach and our history growing up as a data modeling tool that then did application architecture, business architecture, and then enterprise architecture, is we tend to gravitate more towards what we call the business-aware IT professional. Now, they're collaborating with the technology-aware business professionals, and it's that collaboration that version 15 and version 16 then started moving out to capture those non-technical, non-IT, business-centric people that know that they need information to run their businesses better and know what information they need to leverage, and they need to be able to collaborate with IT to be able to have the infrastructure to support their needs. And that's really where we're seeing this, the democratization of the data model. It's that enterprise conceptual model. Everybody tell me what you want out of a customer, and I'm going to build one customer for everybody, and everybody gets to communicate and collaborate around that. And then I'll implement a sliver of that here, and a sliver of that there, and another sliver over there, and all the various different systems that have business processes that manage these slivers of the information will then take over in collecting, managing, storing, and federating and integrating that, and then reporting on it later for our other purposes. But it's that holistic single enterprise view that we need to get the communication and collaboration around. And as I said before, if you're trying to do that down at that physical data model, or even at the logical data model, where we're already thinking too much of a given implementation and optimized for its storage in that implementation, we're already too late in the game to truly understand how that can cross the enterprise and cross the applications to give us that single version of the truth that we need.
I see. Okay, great. Oh, well, I agree that's a great place to start. Well, I'm going to turn it back over to Eric now and see if he has any audience questions for us.
We do indeed, and thank you so much, gentlemen. Good presentations. We have a number of good questions already from the audience, so let's just kind of dive right into those. And I've got sort of a curveball, David, that I'll throw at you in a minute as soon as we get through these. But let's just jump right in. So here's a very good question. One of the attendees writes that data modeling is only as good as the cleanliness of the data. We know that data duplication and corrupted data will result in poor analytic results. What do you do or suggest in order to ensure that this doesn't occur?
So I can take a first stab at that, but I'm sure that William has some even better answers. From an architecture standpoint, one of the problems that we're trying to help folks solve is the definitions and descriptions of what you've got where and how it ties up to that single representation of the enterprise. So customer is a great example. If you have customer data in a bunch of places, you can quickly identify from one conceptual customer representation all the different implementations and then start flagging which ones are duplicates, which ones are not. You can also start tagging these physical representations with quality metadata. So you can say, these are the high quality, these are the low quality, this is where we should get it from, this is how quality's changed over time through different versions, and get a sense of where problems are being introduced. So it gives you a planning and management dashboard over the efforts that you'll need to be able to clean and dedupe the information. But William, I'm sure you've got some ideas on the actual acts of cleaning and deduping that folks can use to help solve the rest of that problem.
Well, absolutely. Data modeling is actually quite important to data quality. I definitely agree with what Ted has said here about data modeling is only as good as the cleanliness of the data. Well, the final system is only as good as the cleanliness of the data that we put in there. But the structure that we build in the data model actually drives a lot of the data quality that will go into that model. But there's another level of data quality, and that is just simply what kind of data are you feeding in there. So my answer is a data quality program, which is an overarching program that continually looks at the quality of the data as presented against business metrics, and there's a finite set of things that can be wrong with any piece of information. It could be incorrect, it could be not referentially integrate, and so on and so forth. I actually have a white paper on this if anybody's interested. But I recommend a whole data quality program that goes hand in hand with any architecture that you do to make sure that you actually do have a good model that is good because of it. It hangs together, but the data that goes in there is clean as well. And clean is the absence of intolerable defects. So that's what we're trying to drive out.
Okay, good. And here's another really good question. One of the attendees writes, what best practices have you used or have you heard about to effectively communicate the iterative enterprise conceptual model to the business stakeholders in order to avoid the perpetual technology black hole?
Wow, that's an interesting one.
Yeah. I'll try to jump on that, and I'll say that I run governance programs, and I encourage all companies to have one. And I didn't get to it in the Q&A, but I did want to point out that is something that's being undertaken by so many companies today, and it's just hand in hand with this architecture morass that we are stepping into. And governance is there to rein it in, keep it under control, and to share information. So it's really your conduit. It's to your benefit as someone that's building these systems, building these architectures, to have a good governance group that's going to understand, share, and drive the direction of. So my answer is data governance.
Okay.
And I think the other dimension to add to that, and absolutely you're right, I think it's the people and the processes and the governance and the stewardship that goes into how you manage the modeling effort and everything else that goes with it. That's going to be a key. But the other is, of course, ensuring that the conceptual model really remains a single enterprise asset. And you don't bring it into, I have a conceptual model for this piece or that piece, this division, that group, this application, this project. So it remains pure above technology and then relates to all the different technologies that will implement it. That also keeps you above that technology black hole.
Well, that's interesting. That's a good point. Okay, good. We got a couple more good questions here, folks, and we have several more minutes, so feel free to send your questions in even late in the game here, and we'll be sure to get them to you. So there was another question just about, and I think you kind of answered it, but there was another question about iterative implementation of these things. So, and this is kind of where my question is going to come from as well, but we'll get to that in a second. But can you kind of talk about where to start with something like this, with a conceptual model, for example? Let's say it's one of these organizations that just got the awareness that they need to do this, and they have a long road ahead of them. Where do you start this process, David?
The best way I start answering that question is we talk a lot about evolutionary versus revolutionary, especially for organizations that have not started already with an architectural principle in place. You've got a lot of metadata out there, a lot of metadata in a lot of different sources, existing models in a bunch of different places. So the first thing we usually start with is farming that metadata into a single repository. Bring it all, import it into Power Designer, and get it stored in Power Designer. At the same time, you're continuously living through the requests for business transformation and change. So then you start documenting conceptually the business drivers and the business representations that go with that at the conceptual level, and then you start using a tool like Power Designer that can transform up and down to start linking the existing physical environments with the conceptual environments. So you bite off a piece that you can chew in an area that has the greatest impact. For the shipping company, for example, it was aligning several core business processes with some core business information across maybe 5 or 6 systems. The rest will follow. And just getting that low-hanging fruit and getting that return on investment gives you that start to the knowledge base and gives you the experience to continue to work this discipline into something that becomes collaborative and part of your day-to-day work, as opposed to yet another chore you have to do after you get work done.
Oh, I see. Good. Okay, good answer. So here's the interesting question that I've got. I've had this sort of dream, if you will, and I'm just kind of curious. I'm going to map out what I would describe as the holy grail of a data modeling tool, and I'm curious to know how much of this stuff is reality right now, how much is down the road, or how much of it is just pie in the sky. But I just imagine this tool that you could plug into your application architecture, and it would crawl kind of like a web crawler does through all of your information systems and come back and give you sort of a blueprint of all the different systems that you have, and then also over time track the data that moves through these systems from one system to another, that sort of integration platform that you hear some big vendors talk about. And then over a period of time, it will give you this truly strategic as-is view of the world that you have right now, and then allow you to identify those areas of overlap and redundancy and so forth, and then start tweaking and refining that model, which is not just a conceptual model, but is an actual physical model of what's going on with a conceptual side to it that you can then amend and refine with those actions being published back to the logical model, if you will. Is that pie in the sky, or how much of that do you guys do?
Well, you're certainly reflecting my vision for this. And it's a bit of science fiction and a bit of science fact today. There's a lot that we can learn from the existing environments. We have interfaces of things like configuration management databases, CMDBs, that we can understand a lot of the current state architecture from. A lot of systems have their own metadata in them now, and they publish that, and that can certainly be farmed automatically through crawlers and things like that. And some technologies exist out there that will create databases from discoveries made by looking through the wires and routers and systems and asking everybody to tell them about themselves and inferring what it can and cannot from there. But at the end of the day, there's still some human intervention that needs to be applied there, and that's mostly the why. Why is it there, and what's it for, and who cares, and who needs it? So getting that physical representation of the systems, this is great. And there's a lot of technologies there that we can use, and more that we need to harvest there to make it even better. But then filtering that and transforming that into a business meaningful representation requires knowledge that just isn't in these systems. It's in people's heads. It's in people's day-to-day lives. It's in the way they go about doing their work and the motivations that drive them. But once we're there, once we have that business representation, transforming back down into actionable change to systems through logical and physical models, that's there right now. We have organizations, a major automotive manufacturer that takes business models and generates and runs systems directly from them. mostly because all the controls are there. The patterns and templates they use are very well controlled. The versions of the systems and hardware and software is completely controlled by this, but then they can get there. The problem is in the real world, and to expand this beyond a given application for a given purpose, we have to take in so many more variables into account that there's still a need for that end stage where the custom developer develops that custom code that wires it all together. So we can get a lot of the way there, and we're getting closer and closer, and the vision is to ultimately achieve that. But there's still some gaps to close and still some time for us all to enjoy some other aspects of our career before we all become architects.
That's funny. Okay, good. And a couple of direct questions here at the end from some attendees. One, can you speak to integration with SAP and how natively will that be done now that, of course, Sybase is an SAP company? I can imagine there's some kind of tight coupling going on there. And then two, one of the attendees wants to know, how do you price this stuff? Is it by user? I know you have an enterprise model and some different flavors, but how does all that work?
So I'll answer the SAP question first. The best answer I can give today is, of course, there's a lot of opportunities within SAP and all of the different SAP businesses to help businesses run better through architecture. And the integration team between Sybase and SAP, now that Sybase is an SAP company, are exploring all of those opportunities. And we'll be publishing roadmaps shortly as we get closer to being able to deliver on any technological changes that go into Power Designer to address those. But we're certainly looking at all of the opportunities that we can bring to SAP customers. And by the way, there's some things we can do right now today, even through partners. We have an organization called Silwood, with a product called Zephyr that gives us data model integration with SAP and other packaged applications. We have an organization called Reichman that gives us the ability to work with content that may be in other SAP partner models to bring them back into Power Designer and start centralizing those there. And so there's a lot of things we can do to help SAP right now out of the gate. And additional technologies we'll be putting into the roadmap moving forward. And then the easier question is, what's it cost you? So you can go out to our e-shop and look at our list prices. They're published. They're fully published and exposed to everybody. But fundamentally what we sell is those three different levels that we were talking about before, the data architect, information architect, and enterprise architect, all at industry competitive prices. And we have two different licensing models. There's a standalone seat, which allows you to license a given computer for the product, or a floating user, which allows you to put a number of licenses out on a server and share them among all architects. And most people, especially when we start talking architecture, use the floating model because then you can buy a number of licenses and serve an even broader community of casual users because they can all share those licenses. And of course, with the web portal, non-modelers have a free portal. The web portal is a free component of the repository that allows anybody anywhere read-only access through the web. And if you want to then send changes back and become an author through the web, there's another license for that, and that's called Portal Composer. So the prices range from anywhere around $3,000 for a seat to about $12,500 for the fully loaded enterprise floating seat that can be shared among multiple users. And so, of course, the best thing is if you have an idea of how you want to use this, sit down with our sales consultants who will be able to size out and price out a best fit between all the different components we sell and what it is that you need to do.
Okay, good. And we got time for one more question here, folks, from one of our regular attendees out there. And thank you, all of you, for these great questions. They really do help us stay on point here. But one of the attendees wants to know which of the models you talked about would be the best fit for that forwarding company you had mentioned, that issue with the packaging and the shipping and all that kind of stuff. He says he used to work at that kind of a company, and following those repackaged parts was a big challenge. So was that the enterprise level that you were talking about?
Yeah, so because they discovered their integration problem was rooted in a business language problem that only materialized when they tried to get all the business units to build one conceptual model, the conceptual data model was really the key asset to them making that discovery and making the changes. They coupled that with the enterprise architecture model, which allowed them to map the various different data assets to high-level representations of servers and services without getting into the technical details, which allowed them to very quickly identify, once they discovered the business language conflict, where in their business those conflicts would need to be rectified at the next level down to be able to make integration work.